again here to IGS and IPC Online Edition. Today we already had a session about Angular Ivy by Manfred Steyer, which was on the first session slot. So maybe you have already heard about Ivy a bit, or maybe you read something about it before, because Ivy has been a hot topic on the Angular ecosystem for quite a while now. So it's all for the best. We do have another talk on Angular Ivy right now, which will focus more on the library side. So please welcome Martina Kraus to this session here. Hi, Martina.
Hello.
Welcome to your talk and have a good time. Enjoy your session.
Yeah, thank you so much. So yes, let me share your screen. Here it is. So yeah, welcome as well from my side. Maybe you saw me already yesterday. I was speaking at a full stage JavaScript day here, and now I have another great session at this great conference. This time I will dig a little bit deeper into Ivy, especially like how you can migrate older libraries to Ivy, or what you have to do as a library author, and of course, how can you still support them if you are a library author with an older library, and maybe you want to use an old library and your application is compiled with Ivy, but they're not compatible with each other anymore. And this I will talk about today. So welcome. If you haven't heard of Ivy, if you maybe missed the talk of Manfred, that's bad because he's a great speaker. No, jokes apart. I will shortly give another short introduction to Ivy. Ivy, in a nutshell, was the new renderer, is the new renderer for Angular. It's the default renderer in version 9. And before in version 8, you were still able to opt in Ivy, but you had to set an extra configuration in the tsconfig file. But from version 9, it's actually the default renderer. The main goal was to focusing on small bundle sizes, because Angular always had a bad reputation of having too much bundle size, and to have a really slow compilation time. So that's why they also focused on the compilation time. And together with Bazel, they actually reached up to 30% faster time of compiling your Angular application. And of course, it was not only that they increased the bundle size, they also took care that you can more easily debug your Angular application. And that's where they actually completely changed the way an Angular app is compiled. And that's why they basically threw everything away that was compiled with the Vue engine and the Vue engine itself, and didn't overtake one concept of the Vue engine. And that's why they're not compatible with each other anymore at all. So basically, just a side note, how to update and how can you actually get Angular Ivy if you are in version 8 or 7 and now you want to update your Angular application. Angular CLI has a implemented schematic for that, ng update, and then it will be automatically updated. As well, everything will be generated for you. If there is something that can't be automatically generated, the Angular CLI leaves you some small to-do comments inside your application, where you then can just search for it, and you have to do some manually steps. What kind of manual steps you have to do and how to change, you might find in this update angular.io website, where you can exactly say, I want to migrate from version 2 to version 10, and what should I do? And then it will tell you, okay, you have to really take care of RxJS, because they did a lot of breaking changes as well from version 2 to version 11, at least, Angular version. And it's a really great web page. If you haven't heard of it, I really highly recommend that you always get there if you want to update your Angular application. But yeah, what about the backwards compatibility? I said that the Vue engine and Ivy aren't compatible with each other anymore at all. But for that, the Angular team even had a solution. They provided 2 different compilers. The first one was the so-called ngcc compiler, an Angular TypeScript compiler, which compiles your Ivy compatible code, like your whole new code that you maybe wrote in your application. And then they also provided the so-called ngcc compiler, the so-called compatibility compiler. And this one we will take a little bit closer. It will take a look closer in our session today, because this compiler converts the old style modules and old style libs to Ivy compatible code. And then the Ivy compiler can take place again and compiles this meta files to and compiles them. And this sounds really great, right? But yeah, what about the libraries? Is it really that easy? And what is if the compatibility compiler doesn't work? And how should I take some changes? But what if I'm not the author of this library? How can I then proceed? That question I want to solve today. Because do I need then to compile my lib with Vue Engine and Ivy? This sounds really, really weird, because I would need to write two different codes, right? I would need to fork my library or create a branch and then basically create a whole new lib again. And is this really the case? That question is also a question I want to solve today with you. But first of all, let me introduce a little bit. I'm a Google developer expert in Angular. So I spread the word around Angular, and I actually really passionate about JavaScript, TypeScript, and Angular. I'm also in my free time doing a lot of research just regarding WebAssembly and C++. So this is also a small field, but today we want to focus on Angular. Additionally, I'm a Women Tech Maker ambassador. That said, I was used to travel around the world and bringing more women to IT and giving them the support, giving small workshops to them, for them improving their self-confidence and actually getting inside the computer science field. As a profession, I'm a trainer and consultant in Angular and web technologies. So I'm giving workshops in Angular. My main topics are actually the Ivy part and the Ivy migration part, and RxJS and Redux, NGRX. These are my main points I talk about and I give workshops on. And of course, as a consultant, I'm developing with customer teams to make their Angular application the best. As well, I'm a co-organizer of Angie Girls. It's the same like Women Tech Makers Ambassador. We are a team of 4 people. We travel around the world and teaching women and girls Angular, a 3-day workshop. So if you might think, yes, cool, I have a company and we would like to support this and maybe organize an Angie Girls workshop, and we do even like remote Angie Girls workshop, then just ping me if you want to know more about this, and maybe we can create a full workshop day. It's for free, so it's for women and girls, completely free, and then they can attend and learn Angular with us. But enough. So why should I support Ivy in the first place if it's completely breaking my whole ecosystem, if it's completely breaking my libraries? Yes, I mean, it's the new rendering engine in Angular, and we can get a lot of benefits from Ivy. We get better build times regarding compilation. I mean, smaller and faster bundles. I already talked enough about that. But it's not only regarding the bundle size improvements and the faster compilation. It's also that, and I'm pretty sure Manfred mentioned that, Ivy is an enabler. Ivy changes the whole new way of actually creating your libraries, of actually creating your Angular application. It sets the ground for Angular elements, for web components. It completely introduces so-called Ivy instructions that you can completely use web components without Angular modules, without Zone.js, like without so many hard dependencies that you actually, not without Zone.js, because Zone.js will be still a hard reference of your package.json, but it introduces a new Zone.js, a new non-Zone.js based change detection. That said, you don't have to run change detection cycle again and again, which sometimes causes performance issues, but you can just trigger the whole change detection on your own, just without the whole Zone.js behind. And this is quite awesome because then Zone.js would be tree shaked out, and Zone.js is quite big. I don't know if you ever saw how big Zone.js is actually in your main bundle. Just take a look. It's like many kilobytes, over 100 kilobytes, and it's really increases your bundle size in the end. And of course, Ivy sets the ground for higher order components that you can actually lazy load a component, put some metadata on it, change some behavior on the component, and then just display it. And this, like a function that returns a component, this is really amazing in my opinion. As well, for those who saw my talk yesterday already, they noticed this graph. I already showed it, but Ivy has some really good size improvements. So up to 40%. And this is really amazing, especially for large enterprise applications. So to shortly get to know how we can migrate our libraries or what we should do, let me shortly explain the differences between the compilation of the Vue engine and Ivy. So basically, the Vue engine rendering pipeline looks like this. We have our HTML template. Out of this HTML template, we create some data template, like an array of instructions, like these instructions who actually built then the HTML. Then the Angular interpreter, which is inside the core framework, takes this array of instructions and renders it the DOM eventually. So looks like this, the data template, which has, as I said, an array of so-called Vue definitions. So we have first an element, div, and a text definition inside this div tag. And then the Angular interpreter, which is more or less just a huge switch case, takes then this Vue definition as an argument and switch cases through the whole definitions. And this is, by the way, as well the reason why Vue engine wasn't tree shakeable. Because during compilation time, Vue engine can't say if you might need create element or create text, the function, because this is like an interpreter concept. And an interpreter concept just calls a function during runtime. And then there is no reference counting on this function possible because it might be that we need this function. And for that, Vue engine always left everything inside the core bundle. And this is the reason why actually the bundle size decreased so much with Ivy. Because in Ivy, it looks more like this. We have the HTML template, and then we create out of this HTML template one single JavaScript file, which calls all these template functions directly, which looks like this. So we have a template function like app component template, and then this I0 means the core framework. So it basically calls directly functions on the core framework. This is inside the component code, inside the compiled JavaScript code. So inside the compiled app component JavaScript code, all the functions are directly called by itself and not taking through a Vue definition array and through the interpreter, directly calling the framework. And apparently now the compiler can tell, hey, yes, you need element start, you need text and element end. I can't tree shake them out, but I can tree shake out everything else. And this is the main reason, by the way, as a side note, why the Ivy bundle size so much decreased. Okay, what is the issue actually of compiling Angular projects? Yes, of course. If we start an Angular application nowadays, we just create ng new and it's already Ivy compatible. And of course, we just write code that is already Ivy compatible, apparently. But we often need to use old libraries, old NPM modules. They are already pre-compiled, but it would be too easy if they are pre-compiled with Ivy as well, right? So of course, they're mostly pre-compiled with a way that is not compatible with the Ivy compiler, with the ngcc, of course. So basically, Angular provides this other compiler to help and support, but sometimes this is not even possible. Sometimes the library can't be compiled to an Ivy compatible meta files that then the new Ivy compiler can take and compile it. And what should we do then? This is the main issue about actually having so many different libraries, and the main issue about compiling Angular projects. And here exactly comes the Angular compatibility compiler. And I want to shortly explain how it works and how we maybe can then insert something inside the older libraries, which make it possible to be still compiled with the ngcc. So basically, this ngcc compiler, scans the whole node modules folder. So it goes through, it iterates through, and for each package inside it, it tries to produce this Ivy compatible version of each package. That said, there is actually an output directory. It depends on the version of the ngcc. And in my version right now, there's an output directory called ngcc node modules. But they also, like in version 8, Angular version 8, it was _Ivy_. So it might differ from, so if you maybe try it out and just running ngcc and looking in your node modules folder, the output directory might a little bit differ. It depends on the version. But in the end, there is an output directory which actually then contains so-called metadata files. And these metadata files can then be compiled with the ngcc. So basically, the ngcc compiler tries to detect folders and libraries which have this Angular package format definition. I will go into that later if you haven't heard of it yet. So it's a special description. It tells, okay, if my library is an APF, this library has a metadata JSON file. This library has some typing files. So the ngcc knows exactly where to find what. And this is like a definition ngcc has no problems with. So ngcc just detects this metadata JSON file and knows, okay, I have this JavaScript file and this typing files to it, so I can create perfectly the other TypeScript definition file for the Ivy compiler then. This is great. I mean, this is the best case. But I mean, we are software developers. We always know nothing is like in the happy world. Nothing is like in the perfect best case. So this Angular package format describes a structure and a format of the package, of course. And there was, like a long time ago, it was introduced because many persons just deployed packages on NPM. And then they decided, okay, hey, we need to define a standard. We need to define a standard like, okay, every package needs to have a README file. Every package needs to have typings file and this metadata JSON file that everyone who's using them and inserting in your package JSON knows how to deal with it and knows how to compile it. It provides several module definitions and of course the entry points, like it know, okay, hey, you want to compile this package in ESM5 or ECMAScript 2015 format or UMD, then here are the links to it. So it's described in the metadata JSON. Here you find the files to it, and here's the entry point, like the starting point for the compiler to start, where all the other references to the other files then can be taken place. And that's the thing. Libraries that don't use this APF can't be really processed properly. ngcc tries to iterate then and tries to find the files and finds the references and tries to produce so-called wrapper files to simulate this entry point somehow. But as you can imagine, this is not always working and not always the best case. So how does it look like? Basically, what the ngcc is doing, it takes from this metadata JSON file, it takes the JavaScript and the correlating typings file, and compile it to Ivy compatible code. All other JavaScript files that aren't, that doesn't have issues actually with the Ivy compiler are just copied. And of course, the metadata JSON is then not needed anymore. For example, how are decorators compiled? Decorators is a good example because the whole way how decorators are compiled with Ivy changed completely. So in a pre-Ivy time with Vue engine, decorators were just compiled to JavaScript and that's it. But to JavaScript, the normal representational JavaScript code, how you would compile TypeScript decorators. But as you maybe already heard and recognized, decorators, like the component decorator, aren't treated like normal TypeScript decorators. For instance, this component decorator, directive pipe decorator, or the injectable decorator, they are compiled to something that's so-called static property files inside this component then. Theta CMP, theta dir, theta pipe. And inside the static properties of this class, of this app component class, for example, there is another function, define component, define directive, which returns a component definition, a component directive. And that's the reason why every component now has all information for it's needed to be compiled on its own, because there is a static property, and in the static property, there's the whole definition of the whole component or directive or pipe. So we don't need to call another framework interpreter to actually for this component to be compiled. Everything is inside this one component. But that said, it makes it even more difficult because now what needs to be done is basically the typical TypeScript decorator to JavaScript compilated code needs to be translated by the NGC to this static property. And this is like a whole procedure that NGC does actually for you. So out of this JavaScript, it creates, of course, an abstract syntax tree and produces partial classes. And then out of this partial classes, I mean, it's really simplified the algorithm, but just like for imagination, out of that, there's many, many steps in between. It's not that easy, like just these 3 steps. It's a little bit more complicated, of course. But out of this partial classes, then it tries to extract the static property definition. So creates this theta CMP and theta dir static properties for the classes to be Ivy compatible. And these are just the steps, for instance, an NGC is doing for you. So, okay, I know Ivy now, I know how it's rendered, I know like what NGC is doing, but what about the libraries now? Yes, I want to separate this topic in 2. The first is like using a library, an older library, and what should I do when I am the lib author? Apparently, I have to tell you something before. If you're using a library, there's not that much you can do except of calling the library author and telling, hey, can you please provide this and this for me that it's working? And some other stuff, and I want to go to that now. And so if you are in an Angular application and you're using incompatible libraries, then you might get often this error, entry points failure. So basically, fail to compile entry point due to compilation error, blah, blah, blah. The main issue here is that the NGC wasn't able to find a proper entry point file. What do I mean with that? I meant that this module might not have been in the APF, like in this Angular package format. And for that, the NGC can't really figure out the corresponding, that's the wrong word, the correlated, yeah, you know what I mean? I don't find the right word now. The appropriate definition and metadata JSON file, and not the file that tells me, hey, you need to, if you want to compile it as UMD, you need to go in this file and the typings file. So it doesn't really knows where to start. But what can you do then? Basically, you could, of course, always make sure your dependencies on the latest version. It's also a little bit easier than it is, so, because sometimes you can't upgrade packages because maybe you're in a huge monorepo and another team is hardly depending on it and you get some conflicts. But what you can do is provide this entry point file on your own. There is an ngcc config file. And this is the file the ngcc is actually searching for if it tries to convert this old library to Ivy compatible code. So you can provide this file just on your own. And basically how it looks is just a JavaScript file that you put in the root folder of this NPM packages. Yeah, I know that, of course, every single time and on your build pipeline, this is compiled every single time again, and then your file is gone because it's overwritten apparently. So you would need to include this in your build step. So you would need to, after npm install, you would need to include a copy paste file build step. And in this config file, you basically just give the entry points on your own. So you tell, okay, I have the input text, here you find the typings, and here's the main file of the JavaScript file, as well for buttons, for example. As well, what you also can do is ignore some specific folders of this NPM module, because maybe actually what you want to use from this library is even able to be compiled with the ngcc converted. But it's breaking because of other modules you might not need. So you can even tell in your entry point config file, ignore these files. And then the ngcc would just ignore them and just try to convert them that are able to be converted. So you can ignore them. The best advice is actually just try to replace this package because apparently in the later run, you might need to replace this package anyway, since the ngcc is just for transition phase. Later on, they will say, okay, we don't support libraries with View Engine anymore. We don't do that anymore. And they won't support the ngcc anymore. But hold on, before you get in panic, this, when I'm talking maybe in the next 5 years, it's not like, okay, tomorrow the ngcc is not available anymore. Apparently not, but like in the long run, I mean, if you have a long running project, you should already consider and maybe evaluating and finding another package. Of course, another common advice is try to avoid these dependencies who are not following the APF. So not just looking at the major version or how many commits or how many issues the package has, also try to figure out if this dependency you want to include in your project is following the APF. And of course, I mean, I said you can call the library author, but as well you can of course open a PR for the library maintainer, because sometimes everything is open source and sometimes the library maintainer are really, really under pressure and everyone is just putting all their stuff of them. Oh, why don't you do this and this and this? So you can just be nice to them because it's their free time often. And so you can just maybe help them and open an PR for them. So this is what you can do. It's not much, of course, but this is what you could do if you need to use an old library. But now the main focus is actually, of course, when you want to use Angular libraries as an author. And for that, I created a poll, or like there is a poll. I would like you, it's already started, and I would like you to, if you already, to take place in this poll, if you're already using Ivy and if you are actually writing your own Angular libraries. I would be interested in that. And I just see already that some of you are already writing your own libraries. So I talked about a transition plan, and this is not really official from the team, but it's more or less from the community, which says, okay, if you have an Angular version 9, and Angular version 10, Angular version 11, these are the recommended settings. Like in version 9, it's still not, you still should use libraries with View Engine. Since version 10, you should use libraries that are compiled with Ivy. And then, of course, in 11 as well, and more. As well, what you can see here is, of course, what is not supported anymore. I mean, of course, since version 9, since version 9 and 10, then View Engine is not really supported anymore in as an application engine. I mean, you can still opt out, but you can't use the View Engine as for the application engine in Ivy than for library engines. So this gives a good overview, like what is supported and what is recommended. So if you're starting a new library, you might think, okay, then I just write my library with Ivy compatible code and just compiling it with Ivy. That's enough, right? Unfortunately, not. And now maybe you should get a cup of coffee because this is really hard. The thing is, I mean, no, don't get it now because I still need you here to listen to me, but afterwards. But make sure you're back with it for the next talk. They're really amazing as well. So you need to compile your library once with the View Engine and once with Ivy. Because there are still so many older applications out there, and so many applications would like to use your library, still using your library. And when you're now just publishing your library with Ivy, you might lose a lot of customers for your library. I mean, when you're just using this library internally in your team and not publishing it on NPM, maybe it's a little bit different because it's a little bit easier to tell your team neighbors, hey, yeah, you're using Ivy, right? So yes, I can't, it's fine if I just publish it with Ivy. That's another story, but we're talking about really publishing it on NPM that everyone can use it. So you need to compile View Engine, your library, the View Engine, and compile it with Ivy, and then publish it on different names and differently on GitHub. Okay, but how? I mean, should I really clone my code and write it once Ivy compatible and once View Engine compatible? There's different ways. So one way is, yes, you create Git tags or branches to do so. I mean, there's no other option if you want to do it like that. But what you also could do is that you create some kind of a detection logic. And people who are already maybe used C++ or C knows this preprocessor thing. Like you can say, okay, if I compile my C file with the GCC or with Clang, then compile this code snippet or insert something, some header library. And this is similar now to this, what I'm now suggesting, that you can insert some kind of Ivy detection logic, like basically you just try to call some Ivy functions or like a component. A component, of course, needs to have be accessed with the ngComponentDef. It's a type with the ngComponentDef key. And if it's able to be that this component has this attribute, this key, then it's highly likely that's an Ivy component. And with this, you could surround your code. I'm a little bit careful of saying this because maybe you already think, oh, this is completely blowing up my library. But this is just a suggestion. This is just something that you could do if you have 2 or 3 little lines of code which aren't Ivy compatible or without being view engine compatible anymore. So you could do something like this for these small lines of code, but you have to do it, because there are some are smaller changes. It's not actually that much. For example, few children is not completely iterating through your whole nested items, just taking the first item, returning the first item, and not all children's. A few children, sorry, not future, a few children. And these are just smaller things you will find here. I could line everything after another, but you will find here, this is a good guide. And especially there are so many migration schematics. For example, if you remember, renderer needs to be renamed to renderer 2. And there's a migration, an upgrade migration, who you can just run your library code through, and then just figuring out, and just that renames everything on its own. And others you will find here, and also the migrations of that. But I would like to talk a little bit more other possibilities for library authors. So, of course, prepare your library for ngcc, because if you can't completely restructure your code now, maybe for a short-term solution could be that you prepare your library for ngcc, that you have view engine code and you compile it with view engine, but this code can be converted by the ngcc. This is one possible solution as well. That said, of course, there needs to be some changes. Mostly, of course, that you provide your libraries in this APF, or at least this metadata file and a proper entry point configuration. And what you also can do, there's a great project by the Angular team, the NGCC validation, and you can clone it, insert your own project inside this NGCC validation project, and the validator iterate through all project that there is inside and tries to figure out if your project is able to be converted by the NGC. And then it actually converts it as well. It's just a validation tool if your library can be converted. If this is the case, in a short and midterm, you might don't even have to create a huge detection logic or things like that. Yes, but in a longer term, it might make sense to have a proper Ivy-only code. And my suggestion would be, if you have many lines that are incompatible with each other, I really suggest you to go the way with creating a branch with Ivy-ready code. Because in the long run, this will be the only branch in the end that survives. And the view engine branch needs to be, of course, supported as well and all good. But in the end, this branch will die. But for this transition, you still need to support both. And the last question I want to answer is, okay, Martina, you talked the whole time about the Angular package format. And do I need to do it manually? Of course not. Otherwise, I would not ask like that. There is something that's called NGPackageAir. This is transpiling your library to an APF. You can just install it inside your project and then basically run it. And how it looks like, I want to just shortly show. And we're running a little bit out of time, so I just show the things you have to insert it here. So basically, this is like just a showcase, and here's my library. And in this library, I have a package.json where I insert, so the APF is NGPackageAir needs that the schematic is defined inside your package.json. So you need to insert the schematic that the package.json is in JSON format. You also need to include a line for your public entry point file of your library, which is in most cases, of course, the public API, like which all files this library is exporting and should be used. And then, okay, additionally optional, but of course it makes sense, a build script. And if you're running this then it actually, of course, creates, compiles the files. And then if you don't tell NGPackageAir, I just want UMD, I just want like as a module definition, I just want UMD or I just want ECMAScript 2015, it creates everything. And then you see in your dist file for all these ECMAScript 2015, your compiled library as a Angular package format. And this really, really helps a lot because it really like generates everything for you and helps you that your library is actually in this format. And we don't want to actually, and here's this, to create all files on your own. Here's this metadata.json file, which I can't open right now. I'm not sure why, but here's this metadata.json file, what you then need, but all the entry points for the ngcc then. So basically, as I said, the NGPackageAir implements this Angular package format, and it can be consumed not only by the Angular CLI, but also with Webpack standalone. It creates this metadata file, type definition, and run some other optimizations. You can read inside inside this repo as well. It has a lot of features, actually, it's great. So to sum up, yes, as a library author, you need to still publish Vue Engine and Ivy. Your library is compiled with Vue Engine and your library is compiled with Ivy. Of course, use the validation library for ngcc. It might be a short-term solution to avoid this two branches thing, that you have one branch with Ivy, one branch with Vue Engine. Of course, definitely what you should do is providing your library with Ivy, and then for that resolving all Ivy issues. And the most important thing is that you follow the Angular package format. When you're writing a library and publishing it, you always should take care of that. So I guess the last 3 minutes are for questions. So I would really love to answer your questions, but if it was a lot of information, really, really overwhelming, but I would really like to get to know if you want to know more, and if you maybe try something out and maybe later you have some question, you can always ping me on Twitter. On my website, you find some other contact details. You can ping me an email. I would really love to help you and to answer your questions. And last but not least, I want to thank the organizers because they really, really doing a great job. It's really amazing. I'm speaking on a lot of conferences and some community conferences. And I mean, what Smart in Media is doing is really, really great. And it's really one of the best conferences in Germany. So thank you so much. And if you have any kind of question, feel free. I'm now going to the chat as well, of course, and trying to answer them.
Well, thank you so much for the feedback and also for your amazing talk you did here, because, you know, without these great talks, we couldn't present these great conferences. And actually, yes, there is a question on the chat or on the questions tab too. And it's pretty specific, so I guess it's better if you can just go and check.
Yep. You mentioned Ivy detection function like is Ivy or is Ivy component, but it does not convince TypeScript to pass when TypeScript typings are incompatible, right? So it will lead to using any type everywhere in the code. Yeah, in the end, yes. I mean, yes, in the end, of course, because it's JavaScript after all. I mean, I just understood it as a yes or no question. So if you need to follow up, please write again if this answers your question. In general, what is your personal biggest advantage you see Ivy brings to developers? Optional NG modules, Angular modules, which comes with lazy loading components, and the whole new higher order components, which completely increases a new way of writing components, and that you don't have to implement a whole overloaded Angular application anymore, but just using components that you need right now. This is my biggest advantage of Ivy. So, libraries created via NG library are now marked in tsconfig as enable Ivy false. Why is it turned off by default? That's a good question. To be real honest, that would be interesting on which Angular CLI version we are talking on right now. I would have thought that if you're using Angular C, maybe you can write a version right now, what you're using. I would have imagined that if you're using Angular CLI 9 or 10, even the libraries would actually not disabling Ivy. That's an interesting question. I have to admit, I'm not sure actually. I don't know. I mean, maybe because there are still so many applications with Vue Engine, and maybe still some work to do with Ivy. Sometimes that they, in the first place, disable it, that you can just compile your application. Okay, when it's 10, yeah, I mean, it's interesting. I really have to admit, I don't know, to be really honest, why it's disabled by default. I can just guess, and I rather talk about things I know that I'm just guessing around, so I can't tell you, unfortunately. Another question. I'm currently maintaining UI libraries, which are still on Vue Engine, but already use it in Ivy projects. What are the main disadvantages currently with this approach? Without the library updated to Ivy, for me, it seems to be work quite smooth. Yes, I mean, definitely. I mean, it can work. It's just like that. I mean, if it's working for you, that's really, really great. Perfect. I mean, it could be just that the converted code of ngcc, like from your UI library, it might be a little bit slower because the JavaScript that is then converted might not be the best if it would be compiled with Ivy directly. That is one case, but if you don't recognize things like that, I mean, you don't need to force then rewriting it with Ivy. You don't have to force it. Just keep in mind that eventually, maybe in Angular version 16 or 17, this will not work anymore. So, and we have really, really frequent release cycles. So maybe it might be faster than we're thinking. But yeah, but if it's working smoothly for you, go on with this setup. I would not recommend you to change anything just to change anything, actually. So that was the last question from now on.
Mm-hmm. So just to point it out, actually about half of the participants said on our survey that they have already written their own Angular libraries. So
yes, I saw that's really great. I was just curious because I did a talk at Buster, and I did a similar talk on Buster where I explained, hey, and you have to do this as a library author and this and this and this. And then I asked, but who of you actually is a library author? And no one raised their hand. And I was like, okay, then it's maybe you're not that interesting. They say it like this. So I was just curious as well, like how many actually of you wrote already a library. And I would really suggest to share your code with libraries and to actually create monorepos. I mean, I can always recommend Manfred Steyer, and he also wrote a book, an ebook of it, which you can download for free regarding architecture, enterprise architecture, monorepos and things. So I would really highly recommend this book as well. So it was just a question more based on curiosity than that I can say something like built on something like that.
Okay, then thank you again for this interesting presentation here at IJS. So we have now 10 minutes left to grab a cup of coffee before we'll continue. Also, I wanted to point out to our participants that you can rate the talks for our speakers, and it would be great if you would use this feature too. So thank you again and see you later. Bye.
Thank you. Bye-bye.